All right, let's talk about how AI actually learns. And I don't mean the sci-fi stuff, robots taking over the world. We're going to look at this from an engineer's point of view. Because AI isn't magic. It's a powerful mathematical tool that's already building our future. Let's dive in. So this is the big question that gets us started. I mean, how is it possible that a computer can come up with a design for something, a physical part, that's stronger and lighter than anything a whole team of brilliant engineers could ever dream up? Well, the answer isn't some secret sauce. It's about completely flipping the script on how we tell computers what to do. And to really get it, we've got to look at the old way versus the new way. We're talking about traditional code versus machine learning. It's a fundamental shift in thinking. And this, right here, this is the absolute heart of it. For decades, programming was all about a human programmer writing every single rule. It was a long list of, if this happens, then you do that. Super rigid. But machine learning, it just throws that whole idea out the window. We don't write the rules. Instead, we give the machine a mountain of examples. We show it the inputs, we show it the correct outputs, and we basically just say, okay, you figure out the pattern that connects these two. So in engineering speak, what we're really creating is something called a function estimator. It sounds kind of simple, but it's an incredibly powerful concept. See, instead of a person trying to write out some insanely complex equation to describe how a system works, the AI looks at all the data and just builds the model itself. It's literally learning the underlying physics of a problem on its own. Okay, so how does it actually learn that function? Let's pop the hood and take a look at the engine driving this whole thing, the neural network, and the simple, almost elegant loop it uses to think. You've probably heard that neural networks are inspired by the brain, and that's true. They're made of layers of little processing units we call nodes. Now, as data flows through these layers, it gets tweaked by a bunch of numbers called weights. The best way to think about these weights is like thousands of tiny little tuning knobs, and those knobs are the only thing the AI can control. The entire process of learning is just figuring out the absolute perfect way to set every single one of those knobs. And the way it tunes them boils down to this incredibly simple four-step loop. First, the network makes a guess, and its first guess is always, and I mean always, terrible, because all its little knobs are set to random. Second, it measures its error. It compares its awful guess to the right answer and sees how far off it was. Third, it works backward and makes a tiny, tiny adjustment to all those knobs to make the error just a little bit smaller. And fourth, it does it again, and again, and again, millions, sometimes billions of times, until its guesses go from terrible to unbelievably accurate. Now, I know that sounds pretty abstract, so let's connect this whole learning loop to something real, something we can actually see. We're going to go back to that first question about designing an impossible part. The process is called generative design, and it's amazing. Right. So we say the computer is adjusting its math millions of times, but what does that actually look like in the real world? How does a mathematical tweak turn into a physical object that's stronger and better? Well, let's watch it happen. Everything starts with a human engineer setting the ground rules. They'll tell the AI, look, the part has to connect here, and it needs to be able to handle this much force. The AI's very first guess, its iteration 0, is basically just a solid block of material that ticks those boxes. Simple, clunky, and not very smart. Then, the AI runs a simulation. It puts that blocky shape under the stress the engineer specified and measures what happens. In this case, error is anything that's inefficient. It's every bit of material that isn't pulling its weight, or it's any spot where stress is building up to dangerous levels. It's basically finding every single flaw in its own design. And here is where you can actually see the learning loop in action. For every little point of error it finds, the AI makes a tiny adjustment. Visually, it's like a sculptor carving away a single speck of unneeded metal here, or adding a tiny sliver of support there. It repeats this whole simulate and correct cycle thousands of times, literally forging the block into its most perfect, most efficient form. And the final result? It's a design that no human would ever think of. It looks weird, almost alien or organic. And that's because it's not based on what we're used to seeing. Our brains think in straight lines and simple shapes. The AI doesn't care about any of that. It's only chasing pure mathematical efficiency. And the results are just mind-blowing. We're talking about parts that can have double the strength-to-weight ratio of something designed by a person. And what's so cool is that generative design is just one tool in this incredible new toolkit. This exact same learning process, learning from data to find the optimal answer, is showing up in every single field of engineering. So, in civil engineering, you've got AIs listening to tiny vibrations from sensors on a bridge to predict a failure months before a human could ever see a crack. In electrical engineering, they're balancing entire city power grids in real time, preventing blackouts. It's the same idea everywhere. Sift through huge amounts of data, find the hidden patterns, and make better, faster, more optimized decisions. Look, the most important thing to get here is that this isn't about replacing engineers. It's about giving them a superpower. It's a tool that can handle all the tedious number crunching and explore thousands of dead ends in minutes, which frees up the human to do what we do best: be creative, solve the bigger problem, and see the whole picture. And that really brings us to the bottom line. This isn't some futuristic tech anymore. It's becoming fundamental. The engineers who get this, who learn how to use these new tools, they are absolutely the ones who are going to be building our world tomorrow. So I'll just leave you with this thought. We just saw an AI learn physics to design a simple metal bracket, but that same learning process can be pointed at almost any problem. So if it can learn to build a better part, what's stopping it from learning how to build a better microchip, or a more effective drug, or a more efficient city? We are just scratching the surface of what's possible.